So let me get there. 20, yeah, page 20.
Yes. And now we're done.
And then, yes, unit 1 is going to be done by the end of next week. It's going to be great. So this is not a great lesson because really it's just a bunch of definitions and some examples. So the biggest thing to know about bias is that bias is, and this is scientific bias. There's all sorts of things that are going on, but this is for statistics, specifically when you're collecting data, things that can happen that affect your data. So when we're talking about statistical bias, we're talking about the fact that our sample, right, systematically does not represent the desired population. So remember, we want to take a sample so we can analyze what might be true about a population. If our sample is skewed, then we're not going to get results that are helpful. And they might certainly favor other, that bias occurs when it favors a certain group over another. Okay, so these are different types of bias you might experience or see. This first one is literally called volunteer response bias. And we really actually have kind of talked about this one multiple times because it's also that idea of a method of sampling is a way to get data as well. But when you do volunteer sampling, you also might get volunteer bias. So if people choose to participate, they might not therefore represent the population. If you think about things like Yelp or even reviews of movie reviews might be different, but like often sometimes like a restaurant review or a hotel review, it's either thumbs up or thumbs down, right? You're not going to get a lot of that middle unless there's motivating factors. So like Airbnb does a nice job kind of like encouraging people to give like honest reviews and stuff like that. And I've had ones on Amazon too. It's like, oh, we'll give you a discount on your next purchase if you do a review. So it's kind of that like, it's a little bit of a piece of candy to get you going. But that is still a type of bias. The example here is, a radio talk show host asking listeners to call in with their opinion about wearing masks, the mandatory mask wearing. Okay, so that was, a big topic of conversation late 2020, 2021, etc. Okay, here is our next one, and this occurs when people are left out of the process when choosing a sample, and so that's going to be under coverage. So we have a lot of, we know it's a lot of hard work to get a good census done every 10 years. And certainly there are going to be people and there's people that don't even want to sign up for government programs because then their, personal information is in a system. There's a lot of fear and mistrust. But then sometimes this stuff then affects the things that happen next. So this was in reference to the 1990 census. There were a lot of immigrants from Latin America that did not return their census questionnaires. Now you might be like, do immigrants have to do one? When the census is for who is currently in the United States at this time, whether they are a citizen or not, right? Unfortunately, in our current state, I would say there's definitely that group is fearful of doing anything interactive because of how local police and ICE are being used to kind of try to deport people. It's not a good feeling. So they would certainly be fearful of government with that. So that creates undercoverage bias. Boom. Next one, non-response bias. This is something that occurs often as well. And it's one of those things that we try to affect. So, for example, that Reese Marketplace survey about selling or doing candy are doing like fruit snacks and beef jerky, things like that. So yes, I've asked my math kids to do it, and all the math teachers are supposed to do it, so, but there's certainly not a grade attached to it. People could choose not to do it, right? So there's this non-response bias to that. It happens all the time. Like, so if a survey was sent out to parents about their attitudes, and they only get 23 responses. That's not enough of a response. So once again, we try to make surveying convenient for people, which that then hopefully encourages people to respond, not just respond truthfully. All right, let's turn the page. All right, so now response bias has its own like separate idea. So people are responding, but even that can go wrong. So that's why a lot of surveys are not like, tell me your opinion. It's more like select a box kind of a thing. I extremely agree. And then like those ideas can then be quantified or averaged even in their own, or put in a pie chart, percentaged, etc. So response bias is bias that's caused by the behavior of the participant or interviewer. So this actually is nicely connected to one of our Against All Odds videos that had the had like the phone bank of people calling places, and they were randomizing which phone numbers they called. But there was also the person in charge of that who was coaching those people, saying, hey, you need to follow the script perfectly, right? You need to say the answers in the right question or in the right order. Please don't adjust the words that you're using. So all of those things, having a well-written survey is, and then implementing it is actually almost the hard parts versus crunching the data, which is usually pretty easy to do because there's only so many ways to do it. So the first thing is the idea of that from your participants, you might get untruthful answers. So questions might be sensitive, like how often do you drink alcohol? You know, or something about like your personal habits that you might not want to share in front of a group, especially, or to a person. That's sometimes why it's nice to take anonymous, fill in the bubble kind of things. Socially acceptable answers. So it's the technical word is corporal punishment, but the do you spank your children? Is like, are people going to answer truthfully to that? Interview bias has occurred, and that can be the interviewer, who the interviewer is. So this took place 1 year after the Detroit race riots of 1967. There were some interviewers that went to get the opinion of Black residents in Detroit if they felt they could trust most white people, and that's already kind of loaded in and of itself. But if the interviewer was white, 35% of Black people said, I think I can trust most white people. But if the interviewer was Black, which meant they could trust the interviewer possibly more, then it was only 7% said they could trust most white people. So who the interviewer is, how they come across, can also affect what's going on. And so that's just, you're not, do you feel comfortable with the person interviewing you? And that's why we do things with anonymity instead, because you tend to get truthful answers. All right, so now this is another one, and this is the idea of ignorance. It's possible that people might say something just to say something, so they don't appear that they don't know something about the subject. There was a study that asked educators how they would rank Princeton's undergraduate business program, and everybody's like, oh, that's got to be in the top 10 in the country, but actually Princeton doesn't even offer a business program. It's just the fact that people were talking about Princeton. Well, if it's from Princeton, it's got to be good, right? So there's that kind of ignorance. You just don't know what you don't know, and it's better to just be like, I don't know the answer. All right, this one. This is lack of memory, because we have brains. So it's giving a wrong answer simply because the respondent doesn't remember the correct answer. So, for example, if I went to a high school reunion and asked people, hey, do you remember what your GPA was when you graduated from high school? I mean, some people might overestimate their GPA or underestimate it, just because why would I keep that exact numerical fact in my back pocket for, 20 years, 30 years? How many years has it been since high school? Mr. Ruffle. People, hang in there, people. Stay with me. You should be taking notes, actively listening. All right, next one. And so there's a lot of response bias, which is why how to write Google Forms and questionnaires is such a good skill, but tough skill. So this one is timing. And it can be all sorts of things with timing. So when a survey is taken can have an impact on the answers. So this one is an example that I'm sure makes sense. If we talk to people in January, the NFL, and the NFL is doing this survey, the NFL reported a poll that revealed football as the nation's favorite sport. Well, of course, right now it's exciting. The Bills might make it to the Super Bowl, right? So we're all wound up. But maybe instead, if we did that poll during the Summer Olympics, we might get a very different selection of answers. And it was a more like, it wasn't given by the NFL. You get a very different answer for what people's favorite sports are. The last one is the thing that I think is trickiest. And this example is fair, not great, but it's the phrasing of questions, right? Phrasing or wording of questions. Do I even understand what the question is asking me to answer? And so it could be that a question is too vague or has some tone in it that misleads you. And it could make very different results. So the question might be like this one says, should the president have the line item veto to eliminate waste? So when a president is signing off on a bill about a budget, should they have to maybe veto the whole thing, or can they veto parts of the thing? Does that make sense? So this one, people said 97% said yes. This one, should the president have the line item veto, option or power? This is 57% said yes. So clearly, when you take the context out of it, it has good and bad implications. Is it only in this scenario that we want him or her to have the veto power, or is this the example they're sharing so we get more people to say yes? Okay. So that's wording. So then bias is different from error, which then you're like, my mind is going to explode. But just take that with a grain of salt. The questions are not, but that would not be the thing that I'm going to ask you to explain what's the difference between error and bias. But there are two different types of error, and it's helpful to know the difference. We always have sampling error. Okay, there's always, in the best statistics, some level of error. It is okay. It is expected. And the reason why it's okay and it's expected is a sample is never the exact same thing as a population, right? A sample is never perfectly perfect. I need to spell better. Perfectly matching a population. So that's why when we do a statistic, like 57% say yes, there will be a plus minus 2% sample error. It is part of the process. Okay. A non-sampling error you guys experienced during that whole entire pumpkin activity we did. We had people that made, I'm going to change that wording. A non-sampling error is mistakes when collecting. So did I go to the right pumpkin patch? Recording. Did I write down the right number? And analyzing data. So did I type the right numbers into my calculator, or did I accidentally use my random numbers? Did I look at the wrong, did I have the wrong title on data and make a mistake when talking about different forms of sampling? So those, it's not a sampling error just that's due to chance. A non-sampling error is like an error in process. So this is not good. So it's an error in process, and it affects your results, and it could cause your results to be tossed out the window, right? So when somebody makes a mistake in like the double blind thing, that's such a serious mistake that it could ruin the whole entire experiment. Okay? All right. So then the last thing is one more type of bias, which is on the next page, and it's connected to a pretty interesting story from history. During World War II, a statistician by the name of Abraham Wald was asked by the British and U.S. Air Forces that were in England to help with, bless you, to help with the idea of how to get more planes that have flown from Britain over to France and towards Germany. How do we get more of those planes to be able to make a complete flight, not lose men, not lose equipment, et cetera, and so on? Is there ways that we should reinforce them? So we're going to look at something in reference to this that's called survivor bias. Okay. And I think this one it's kind of a fascinating piece of history. So let me just pull that up for you. So survivor bias. We go here. All right.
Hi, I'm Eleanor.
I'm Chris, and this is IFL Science.
And we're here to tell you all about survivor bias and World War II planes. You've probably encountered survivor bias at some point. Think of the person who tells you,
"My gran smoked like a chimney and she drove the wrong way down the freeway every day of her life and she lived until 103, so it must be fine."
or something along those lines anyway. These are examples of survivor bias, which goes like this. These activities look less dangerous than they are because you're one of the survivors.
There's a reason why you don't hear many anecdotes like,
"My gran smoked like a chimney and drove the wrong way down the freeway every day of her life, but she died the first time when she was 10.
and that's because they're all too dead to tell them.
During World War II, the Americans wanted to reduce their casualty rates of their air squadrons. Many planes came back riddled with bullet holes in 3 main areas: the fuselage, the outer wings, and the tail.
They came up with a solution to reinforce the hell out of the areas that had been filled with the enemy fire, which seems logical enough, given that those are the areas that look like they're being hit.
However, the reason why this is such a great example of survivor bias is that the only data they had to go on was from the survivors. Before they could start to reinforce the areas, Abraham Wald, a Hungarian Jewish statistician, took a look at the data and realised the flaw in their reasoning. In essence, the bullet holes in the fuselage, outer wings and tails on the planes that survived shows this: if planes could be shot full of bullets in those 3 areas and make it back, That meant that being shot in those areas wasn't very dangerous to the planes.
In fights, if you assume that planes are shot pretty evenly over their bodies, that means that the ones that didn't make it back likely had bullet holes in other areas. His solution was to account for the survivor bias and suggest that they should reinforce all the areas that didn't have bullet holes.
It may seem counterintuitive, but to increase the chances of survival, sometimes you have to listen to those who didn't. Thank you for watching IFL Science. Please subscribe for more content like this.
So Wald's decision was you need to do the nose, right? And the engines, because that's where those planes aren't making it back, right? So that's where the armor needs to go. And of course, armor is heavy. And if there's more armor all over the planes will not be able to take off, and or they use more fuel, and that means they cannot travel as far. A little bit of World War II history, peeps. Woo! All right. So that means Unit 1 is essentially done. Applause. We're going to do two small activities left, but we also have a quiz. So you received a packet yesterday, right? That has you going through the vocabulary. You should work on that with the time that's remaining, unless you need to take a nappy nap. But I don't know if I really want the principal to come in and see you all napping. That might be a little bit weird. So, the other thing that was interesting, and I'll just do this one because it's kind of in the mood of, hey, we like football. NPR is National Public Radio, and they do a lot of great short stories, 2 to 3 minutes long, about different things that happen in science. And so this was one from 2 years ago that we can't listen to anymore from NPR. It's just not active on their site. But I really like this. And it was a study that shows that NFL jersey numbers are linked to perception of body types. So it was last period I had Yancey, who was number 3, and Ethan, who is number 41 in the room. And numbers on football teams are assigned by position, kind of. So I think I'm going to let the AI read this a little bit just because I'm not as good at reading. Although she does a bad job on some of it.
The NFL season gets underway tomorrow when the Detroit Lions visit the Kansas City Chiefs. Football is a numbers game, and there's been a shift underway in the numbers on players' jerseys. NPR's Gabriel Spitzer says a new psychological study may help explain why.
All right, so here we go.
Wide receivers used to only wear numbers in the 80s. Then, in 2004, the league changed the rules and allowed them to instead pick a number between 10 and 19. Within a few years, a ton of them had chosen the lower numbers. Kevin Seifert, a staff writer for ESPN, did a quick census and found that nearly 80% of NFL wide receivers had made the switch. He was curious about why.
So now this is his voice.
In talking to some of the players who did it, many of them kept talking about how they felt like they were faster in a number that was smaller. A lot of them said they just thought they looked better or thinner.
All right.
Seifert wondered whether this was a real thing. Do people associate lower numbers with swifter, svelter athletes? He contacted a UCLA psychology professor named Ladin Shams. She was very clear that she didn't have any research to back it up, but that it would make a lot of sense. The way the brain works is that, over time, you might associate smaller numbers with smaller objects.
All right. So now then she was part of the interview.
So that was just conjecture, a hypothesis. So because there was no prior research, we decided to test it ourselves in my lab.
Yeah, hopefully she reads this part right.
Shams did just that. She showed people images of football players of various body types in a random jersey number and had them rate the player's slenderness versus huskiness. She says lower numbers were strongly associated with the perception that the player was thinner. Even a tiny difference mattered. 17 was seen as slimmer than 19. Of course, some numerals are wider than others, so to make sure that wasn't affecting people's perceptions, she tested out numbers that had the same digits but reversed, say, 18 versus 81.
And we got the same results, and we realized the effect is actually very robust. Shams says what could be at work is a learned association between high numbers and large size. A 20-pound bag of rice is bigger than the 5-pound bag. Our brains keep track of the statistics and the regularities in our environment, and then they use that information, and that forms expectations that shape our perception. And this is happening all the time, unbeknownst to us. This year's NFL season, so that was 2 years ago, 2023, has yet another twist. For the first time, players will be allowed to wear the lowest number of all, 0. If number 10 or number 13 makes you look thinner and faster than number 84 or 86 or something, I wonder what the perception of 0 will be. And so this was an actual study that was published in the journal of PLOS 1, which I'm not sure what that PLS stands for, but I certainly can look it up.